Hey, this is Mr. Ariel. I'm here today with some practice problems about the energy of light. You should have a worksheet like this and make sure you have a calculator as well. Let's go ahead and get started. Now in this box at the top with equations to use, you get to have these equations anytime you need them on a quiz or a test, but there is some stuff we need to add to this paper. In this equation over here, this c right here represents the speed of light. And so that is actually 2.998 times 10 to the 8th meters per second. Now over here, this little symbol, we got that back in the notes, that's wavelength, and that gets measured in meters. And then the V right here, that's frequency, and that gets measured in a unit called hertz, Hz. Now over on this equation, that's energy, that gets measured in joules. Then this is frequency again, same as it was. And this value right here, lowercase h, that's called Planck's constant, and that's a value of 6.626 times 10 to the negative 34th joules times seconds. Now again, like I said in the notes, we don't have to know where these equations came from or why they work the way they are. This is really physics that we're using in part of chemistry. So let's just get into the first problem. This question says, what is the frequency of electromagnetic radiation that has a wavelength of 3.8 times 10 to the negative 7th meters? I don't know about you, but I like to start identifying values that I'm given. And so that's going to be wavelength. And I'm looking for frequency, and that is in my equations, that's V. So if I copy down both equations right now, notice that frequency is in both equations, and so that might make you wonder, which equation do I need to use? But if you look right here, the c, that's the speed of light, and I know what that number is, and I was given the wavelength, and so this would be the equation to use right here, because I don't have enough information about energy to solve this one. So now I'm going to plug my numbers in. The speed of light, that's 2.998 times 10 to the 8th meters per second. That's equal to the wavelength, that's 3.80 times 10 to the negative 7th meters, and that is times frequency. So to solve for frequency, I need to divide both sides by 3.8, and of course that will cancel right here. And I'm kind of flipping sides of the equation because I think it looks better this way. Now, if you're plugging these numbers in yourself on the calculator, and I think you should because it'll help you get some practice and make that Moodle quiz a little bit easier to wrestle with. When you plug this number, the bottom one, when you divide on the calculator, you're probably going to need parentheses around the value to protect the order of operations. At any rate, the correct answer here, when you work out the math, is 7.89, that's rounded off, times 10 to the 14th, and that's frequency, and so the unit is hertz. I definitely advise plug those numbers in the calculator, see if you can get this value to show up, and if it doesn't, try it twice, and then I'm happy to teach you how to use scientific notation on your calculator. Let's move on to the second question. I just went ahead and copied my equations again. This one says, what is the energy in joules of a photon of light with a wavelength? So I'm going to make my symbol, that's wavelength, and we have a number for it. Now, if we're looking for energy, the only equation to start with would be this one over here. And I do know what the value of h is, that's Planck's constant, it's up at the top of your page, but I don't know what frequency is. And so it looks like I'm going to have to use this equation right here first in order to figure out v, and then we'll come back and plug it into this equation. So c, that was the speed of light, and we said at the top of your page that's 2.998 times 10 to the 8th meters per second. And then the wavelength right here, that's 4.20 times 10 to the negative 7th meters. We're going to multiply that by frequency. Now I am going to speed this up a little bit because it's exactly the same as the previous problem at this point. And so I divided both sides by that wavelength, and so that cancels out. And then flipping sides of the equation, and with the calculator we can get 7.138. And I'm putting this little symbol right here to remind me that there are a lot of digits on the calculator that I need to keep up with. We cannot round yet, because if we do, and then we round off at the end of the problem, that's introducing error that we didn't need. All right, so I forgot to put the unit on that. That's frequency, and it's hertz. And so if you've lost sight of the goal right now, we're trying to figure out energy, which is right here in this equation, and we knew Planck's constant, and so now I can just plug this number into my equation. Let me just do the work over here. Energy is equal to Planck's constant, and we said that was 6.626 times 10 to the negative 34th joules times seconds. And so now we're going to multiply that by the frequency, and that's the 7.138, and I'm going to plug in all those numbers on the calculator. I have not gotten rid of them. That's 10 to the 14th hertz. Now, ask me in class if you want to know, how do I get these numbers on my calculator, all the ones that didn't get rounded off? Ask me if you don't know how to get them to show up in the next calculation without typing them in painfully. There's a quick way on the calculator to get that done, and typing in all of those extra digits that we left there, that's a real pain. All right, when you plug that in on the calculator, you will get 4.73 times 10 to the negative 19th, and that's joules because it's energy. So this was kind of a two-step problem. We used one equation to solve for a value to plug into our second equation. Now, if you want to hit pause and try this third problem on your own, go ahead. Now I'm going to go ahead and work it out step by step. So we know this number right here represents the energy, and we want to solve for wavelength. So I'm going to copy that equation down, E equals h times v. And so I know I can use this number, 5.30 times 10 to the negative 19th joules. That's going to be equal to Planck's constant, and that's the 6.626 times 10 to the negative 34th joules times seconds. And then that's multiplied by the frequency. So I'm going to divide both sides by Planck's constant. And of course, that cancels out. That works out to be 7.998, but I got to keep all those digits on my calculator, and that's times 10 to the 14th. That's hertz for frequency. So now I can take that other equation, that speed of light is equal to wavelength times frequency. I can just start plugging in my numbers. That's 2.998 times 10 to the 8th meters per second. That's equal to wavelength multiplied by frequency. And so this number right here is just going to go in right there. So that's 7.998 times 10 to the 14th. That's hertz. And we'll divide both sides by that number. That cancels out. And so wavelength, that works out to be this many meters, but that's a lot easier to write if you do it in scientific notation. So that's 1, 2, 3, 4, 5, 6, 7. So it's going to be 3.75 and times 10 to the negative 7, because this number is tiny. And so that's my answer. So that's it for these 3 practice problems. I hope the video has been helpful to you today. And as always, thanks for watching.